Hi, it's Mr. Baker here with another physics video, and today we're going to be looking at electrical resistance. Okay, so today we're going to be looking at resistance, and we're going to be answering this question: what is electrical resistance? Okay, so here you can see a piece of wire that we've kind of zoomed in on. The grey circles are ions or metal atoms inside the wire, and the blue circles are electrons. And you can see the electrons are moving through, and sometimes they're bumping into the ions there. As they move, electrons collide with ions in the conductor. The electrostatic store of energy is transferred to other stores like thermal energy. The resistance describes the potential difference required to drive a current through a component. So this is what a resistor looks like, and we would say that resistance is the opposition that an electrical device has to the flow of electrical current. Now that's not really the definition, but it's a way of thinking about what resistance is. When you have resistance in a component, it slows down the electrical current. It makes it harder for the electrical current to flow through it. And all devices have some resistance. A resistor is a device that has a particular resistance. And this is the circuit symbol for a resistor. Okay, so we've got another great simulation from PhET here. What we've got is a series circuit. Series circuit here has got 3 cells in series. Each of these cells is 1.5 volts. So the total potential difference here in this series circuit is going to be 4.5 volts. We've got a resistor in series with these, and then we've got a way of measuring the electric current, and you can see the current is 9 milliamps. The resistance is shown by the little black dots in the red cylinder there, and the electric current is shown by the sides of these arrows. You'll also be able to see the relationship between voltage, current and resistance by the size of these letters as well. And what we're going to do is we're going to keep the potential difference constant, and I'm going to vary the resistance, and I'm going to see how the electric current changes. Okay, so I'm going to make the resistance bigger, and you can see as I make the resistance bigger, the electric current gets smaller. As I make the resistance smaller, the electric current gets bigger, and we can say that they are inversely proportional. So for a constant potential difference, as resistance increases, electric current goes down. As resistance goes down, it's easier for current to flow, and so it goes up. And that leads us to the resistance equation. So this is our equation for resistance. Resistance equals the potential difference divided by the current. So potential difference is measured in volts, current is measured in amperes or amps, and resistance is measured in ohms. So if we were to rearrange that equation, it would lead us to this: potential difference equals current times resistance, and current equals potential difference divided by resistance. And one way you can use to rearrange the equation is a triangle that looks like this: potential difference on the top, and then current and resistance on the bottom. So some people like these triangles and some people don't, but if you wanted to find what current was, for example, you would place your finger over the current, and then you'd see that current then is potential difference divided by resistance. If I wanted to find potential difference, I would put my finger over that, and I'd see that potential difference equals current times resistance, and if I want to find resistance, it'd be resistance equals potential difference divided by current. Okay, so how do we measure resistance then? So this is a circuit you would use to measure the resistance of a lamp. The resistance of the component can be found by measuring the current through and the potential difference across it. So we've got to remember that we always put an ammeter in series with the component that we're measuring. So here the ammeter is in series with the lamp, and you put a voltmeter in parallel to the component you're measuring. So here you can see the voltmeter is in parallel with the lamp. And so we take our measurements, and then we would use our equation: resistance equals the potential difference divided by the current, and we'd find out what the resistance of that lamp was. Okay, so let's look at an example then. So calculate the resistance of a lamp if a potential difference of 12 volts causes a current of 3 amps to flow through the lamp. Okay, so let's remember DESRA. So D, first of all then, for data. So data here, we've got potential difference is 12 volts and electric current is 3 amps. E for the equation here, so the equation is resistance equals potential difference divided by current. S for substitute, so we substitute in our potential difference and our current, so the potential difference is 12, so that goes at the top. The current is 3, so we've got 12 divided by 3. Here we don't have to rearrange, so we don't have to worry about that. And so we can move straight on to the answer, and the answer is the resistance equals 4 ohms. Okay, so this is what you should be able to do then by the end of this lesson. You should be able to state how resistance affects the size of a current in a circuit, and you should be able to calculate the resistance for component, and you should be able to calculate the resistance for component and the voltage across it. Okay, so what is electrical resistance? So resistance is the opposition that an electrical device has to the flow of electric current. Its definition compares the size of the potential difference across the component needed to produce a particular electric current through it, and we say that the resistance is the ratio of the potential difference to the electric current, or resistance equals potential difference divided by current. Okay, so that's been another physics video all about resistance. I've been Mr. Baker, and I'll see you next time.